Assalamu alaikum, AS Math P1 students. Most students learn a shortcut for inverse functions, but Cambridge tests much more than that. This lecture or this lesson is going to be about that. So, for example, let's say if I have given you fx is equal to x squared, can you find the inverse of it? Those of you who have learned it in their O levels or the ones who are retaking P1, but I hope they don't just blurt it out directly that yeah, f inverse x is going to be under root of x, because that's going to be incorrect, right? That's absolutely wrong, because fx is equal to x squared. This thing does not even have an inverse unless we change the domain. And if you have been following our lessons, you will know that this fx is equal to x squared is actually a parabola, a standard parabola, and an inverse of a function is nothing but a reflection in the line y is equal to x. And if so is the case, then this is going to give us something that is going to be similar to a hyperbola, which is not even a function. Therefore, the inverse of this parabola, or fx is equal to x squared, does not even have an inverse unless it does not exist, unless we change or deal with the domain of it. And today's lesson is going to be about why. Just to recap very quickly, in our first lesson we discussed what domain was. Basically, domain was all the possible values of x that we consider, right? So it's all the possible input values that we take, which usually and most of the time, so if you're talking about the xy plane, or if you're talking about the Cartesian plane, which is considered here on the x-axis, and for those values, for example, if our function is a parabola and our domain is this, then our range is only going to be this, which means that it is going to be from here to here considered on the y-axis. So it is those values of y or of the function that we can consider. So range is the values, the output values, the corresponding output values, right? Now, what are the composite functions? If fx takes an input of x, then a composite function f g of x takes an input of another function, that is g of x, as an input, right? So now, if composite functions they combine functions, then inverse functions, they undo them, right? And we are going to discuss this in a while. So as we were doing the machine analogy, in which we were discussing in functions that the function or the rule is applied on the input variable and produces an output variable. Similarly, or vice versa, or in a contra, inverse does exactly the opposite. So if an output, so here this was an input and there was an output. If the process is reversed, if an output is fed into the inverse function, then it produces an input. So for example, if you apply f inverse on f of x, then it produces an x. Similarly, if you apply the function on f inverse of x, then it also produces a result of x, and we are going to do quite a few examples in this lecture on y. Now, perhaps this is the most important idea when we are discussing or when we are studying inverse functions, that the domain and the range of functions swap. So whenever you're trying to find the inverse of a function, then if f of x was a function where x was greater than a, in order to give a range of fx greater than b, then f inverse of x is and provided that f of x was a one-to-one function. First of all, this thing we are going to study this in a bit. Then f inverse of x will have a domain of x is greater than b and a corresponding range of f inverse of x is greater than a. So that's a very important idea, that domain of a function is equal to range of its inverse, and range of a function is the domain of f inverse. We can do a few examples here. Now, I hope so you can go back and take a screenshot if you want to take it down. Now, let's say this is some function, right? So let's say this is f of x. Now we know that f inverse of x, or inverse of a function, is nothing but its reflection, but it's a reflection on the line y is equal to x, right? Yeah, so this line is y equals to x. This is the function, and here we have inverse of a function. Now, let's say we were talking about this domain. Let's say we were talking, or let's say we were just talking about that fx was a function. And let's say we were talking about x is for the domain x greater than -1. Let's say this is -1, right? Now, this becomes -1 when we inversed it, and for this the range of f of x was greater than 0, right? Now, as you can see, once this graph was reflected on the line y is equal to x in order to produce a corresponding f inverse function, now the domain of f inverse of x is what? If we just take this part of it, because that's the domain, if we just take this part of it because that's the domain, then this is getting reflected here, right? So as you can see, so f inverse of x will have a domain because we are considering this part of it. So you can see that f inverse of x has a domain x is greater than 0, which was similar to the range of f of x, and f inverse of x has a range of greater than -1. As you can see here, I will highlight it one more time right here. So you can see that the range of values is greater than -1, right? So you can see that the domain of the function became the range of the inverse function, and the range of the function became the domain, it became the domain of the inverse function. And this is what we have written here as well, and I really want you to take it down, because these are the 1 mark and 2 mark questions that Cambridge always or 90% tests you on every time in the CIE papers. Just like we discussed at the start of this lesson, that inverse only exists for a one-to-one function. So for example, if this is a function, then we cannot reflect this on the line y is equal to x. Why? I mean, algebraically you can find the inverse, but then it's not the inverse by logic is not going to be valid, because if I were to reflect this on the line of, let's say, let me use another color. If I am reflecting this function, let's call it y equals to fx. Let's call this y equals to fx, and this is y equals to x, which is the line of reflection. If I had to sort of, reflect the line, right, on reflect this function on the line y is equal to x, then it would go like this, right? So the parabola is going to turn into a hyperbola, and now through a vertical line test we can see that for an input value we have multiple output values. So this becomes one to many, and now this relationship is not part, this does not come under functions, right? So this will no more be a function. However, when we say one-to-one, that means that we can specify the domain of the pair of the actual function. So let's say this is y equals to f inverse of x. Now, if I had specified the domain of this function from the turning point and like this, then the other from here or from here or from here, or let's say from here and backward, or from here and backward, which means that the turning point is not included, then the resulting f inverse of x will also be. So for example, let me give you an example. So if this was only the part that was being considered, so if this was a, then the domain was and let's say that this was a turning point, then the domain would have been, for this the domain would have been specified at x is greater than a. Then we can, then this function is a one-to-one function, and the corresponding f inverse function would also have been possible like this, right? Because the corresponding function would also be a a one-to-one function only, because as you can see there, on a straight on a vertical line test, it's not intersecting the inverse function at 2 points, right? Therefore this is a one-to-one function. Now as soon as your domain crosses the turning point, let's say it starts from here, then the corresponding f inverse function becomes like this as well. And now through a vertical line test, now it's intersecting at 2 points, right? Can you see? Therefore we cannot do this. So the minimum, so if let's say they're saying, so the examiner in the in P1 paper usually asks that the dom is, so if inverse is possible for a function y equals to fx, and the turning point y equals to fx, and the turning point is at a and b, then what is and the domain is x is greater than, let's say, k, then what is the minimum value of k? Then you would say that k, the minimum value that k can take would be this a, right? Because this is greater than inequality, then this is going to be the value of k for which the inverse will exist. I mean, the inverse will also exist if it starts from here. However, if we are being asked to find the minimum value of k, then this is going to be at this point. Okay, now we will move on from here to our next section. Now CIE loves to test you on the restricted domains, right? And it so for example, let's say they've given you a function fx is equal to x minus 2 whole square plus 1. Now you can clearly tell, those who are retaking or those who have done their of course, everyone who's doing their A levels, you have done your O level or IGCSE math or AD math, which is better. So you automatically knows that 2 comma 1 is going to be the turning point of this function, and since there is a 1 here, or a quantity which is greater than 0, therefore this is a minimum type function. So this is 2, this is 1, so the curve goes like this, right? And let's say if I take x is equal to 0, then this becomes 5. Okay, so the curve goes like this. Okay, this is what this function is going to look like. Now if we are asked that given no restriction on the domain, which means that x belongs to all real number, does the inverse exist? Then we are going to say that there does not exist any inverse. However, if someone tells us that either the domain is greater than or equal to 2, or greater than 3, or x is greater than 5 or something, or they say that x is less than 2, less than and equal to 2, less than 1, x is less than 0, or x is less than minus 5 or something of that sort, where in the domain the turning point is not existing. So what I'm trying to say is that the domain is either from here to here, or from here to here, or from here to here, or in the other case the domain is from here to here, turning point and backward, or from here to here, or from here to here, then there is a possibility of an inverse existing, right? However, if the turning point is involved, then of course there can't be any inverse, right? If the domain that we are taking involves a turning point of the function, then of course the inverse will not exist, right? Okay, now Inverse will exist. Now, how do you find the inverse? So first of all, let us in this first do how we actually find inverse. So for example, you're given fx is equal to 2x plus 1. So first thing that we always do is remember these four steps. Number one, you put y equals to fx. Number two, you so this becomes, wait, let me use another color. So this becomes y equals to 2x plus 1. Then you swap x with y. So the domain and range of the inverse function of the function also swaps when it goes into the inverse. So now this becomes x is equal to 2y plus 1. The third step is make new y the subject, or I will put the new y the subject, right? Make sure that you are copying these four steps down. So this becomes x minus 1 upon 2 is equal to y, right? So now the fourth step is very straightforward. New y is f inverse of x. So you will write down f inverse of x is x minus, or rather half x minus half. Half x minus half. Now you will see that all of a sudden this 2x, which was steep, now this has changed into a gentle one. So you can clearly see that this is a reflection on the line y is equal to x. And this one, which was initially, so if I plot it here, if I plot it exactly or try to plot it, so if this is 1 and y, so this is negative half, right? So the function was going like this, okay? Now, inverse function is now going to go like this. So this is going to pass through negative half, and the gradient is going to be, my bad, and the gradient is going to be half as well, right? And clearly this is a reflection on the line y is equal to x. So this is the line y is equal to x, this is y equals to fx, and this is the inverse function that we just found, right? So this is how you do it. Now, if in the example that we were doing above, if let's say you had to find an inverse of x minus 2 whole square plus 1, then what you're going to do, and by the way, we are discussing restricted domains here. So first of all, you are going to swap x and y. So this becomes x is equal to y minus 2 whole square plus 1. Now this is x minus 1 under root plus and minus, and 2 plus and minus equals to y, which is equal to f inverse of x. We are going to do quite a few examples in order to anchor this or solidify this concept in your heads. Now this is 2 plus under root x minus 1. Now understand that if we are saying that the domain for this function is x is greater than and equal to 2, because the turning point exists at x is equal to 2, and we are not, so in the domain we are not going beyond the turning point so that the inverse manages to exist, right? So it exists. So this is the domain. This is the domain of the function. Domain of fx is x is greater than and equal to 2. Therefore, range of f inverse should be greater than and equal to 2. So for this to be greater than and equal to 2, for this to be greater than and equal to 2, you can say, and because we already know that the cert cannot produce a negative result, therefore, so we have two options. So this is 2 plus under root x minus 1, and we know that this result is always going to be 0 or positive. So if we add something to it, then it is fine. We are going to be in our desired range. However, if we go on subtracting a positive value from 2, then we are not here, right? Therefore, we are going to neglect the negative sign here, and we are going to just restrict with f inverse of x is going to be 2 plus under root of x minus 1, right? So such question in quadratics appear very, very frequently in your CIE papers. So again, what is the process of finding an inverse? We already did the restricted domains, and Now, whenever you are given any function, let's say y equals to 2x squared plus 5x minus 8, and and this is f of x, and you're asked to find out f inverse of x, and you're given that this is greater than and equal to a. You are told that inverse exists. F inverse of x exists. Find, or rather the domain is x is less than and equal to a. Find the greatest value of a. Now let's see. So first of all, our first step is going to be, and this is an examiner style question. So fx is going to be, we do the completing the square method. So this becomes x squared plus, I hope you guys remember this, but we will be covering this in our next lesson in case you guys don't know. So now this becomes 2 square bracket x plus 5 upon 4 whole square minus 5 upon 4 whole square, that is 25 upon 16 minus 8. So this becomes 2 x plus 5 upon 4 whole square minus 25 minus 64 upon 8. So minus 25 minus 64 is going to be minus 89. So this is going to be minus 89 upon 8. So this is our completed square form of our actual function. So we can see that our function, okay, looks something like this. So first of all, this is a minimum type function because our value outside the bracket is positive, and we will discuss in quadratics in the next lesson that why is it so. So this is negative 5 upon 4, and this is negative 89 upon 8. So our function goes, we can roughly sketch it like this. Okay, now they're saying that the x is less than and equal to a. So and function exists. So now the inverse exists, my bad. So either, so if we, let's say we take a here and the domain is b is less than and equal to a, then we are talking about this function. The inverse of this function doesn't exist. Let's say I take a as 0. Let's say a is 0. Then again, we are talking about this function. It involves a turning point. Therefore, no. Let's say I take a as a negative. Let's say I take a as negative half. Again, this means that, so if this is a is equal to negative half, still we are talking about this which involves the function, the turning point. Let's say I take negative 2, then this is fine, this is a one-to-one function. Let's say I take negative 1.5, that's fine, it does not involve. Let's say I take a is equal to negative 5 upon 4, again this is fine. However, if I move, so this is negative 1.25, even if I move negative 1.24, it is going to automatically include a turning point, which in turn, when I reflect it on the line y equals to fx in order to y equals to x in order to find the inverse, this is going to cause problem because the resultant inverse function is not going to stay a many to one or one to one function. On the contrary, it's going to become one to many function, which is not possible and which we discussed in our earlier videos in quite some length, right? So now the standard procedure, so we realized that the domain is going to be x is less than and equal to minus 5 upon 4. Now when I try to find the inverse of it, now I'm going to remove this here because I need to do some working. So first of all, I'm going to change this fx into y because in order to make my life easier, this becomes 2x plus 5 upon 4 whole square minus 89 upon 8. Now swap x and y. So this becomes x is equal to 2 times y plus 5 upon 4 whole square minus 89 upon 8. Now the third step is going to be you make this new y the subject, right? Now in order to make this new y the subject, you bring this 89 upon 8 here, you add 89 upon 8 on both the sides, and then you divide this by 2 on both the sides, and then you take under root in order to have y plus 5 upon 4. Now this value is going to be plus and minus. Therefore, and and when you subtract 5 upon 4 from both the sides, this becomes negative 5 upon 4 plus and minus half x plus 89 upon 8. Now we know that the domain of the function was this, so the range has to be also less than and equal to 5 upon 4, which is only possible if we consider the negative only, because if we consider a positive, then a positive quantity, this is also going to be positive. If it gets added to negative 5 upon 4, then our range is not going to be less than minus 5 upon 4. Therefore here we are going to remove this, and we are going to say that our inverse function is going to be negative 5 upon 4 negative under root half x plus 89 upon 8, and this is going to be your answer. Okay, and if you so the domain, the range of this one is f inverse of x is less than and equal to minus 5 upon 4, and the domain of f inverse of x is going to be what the range of fx was. The range of fx was greater than and equal to negative 89 upon 8. So the domain of this is going to be greater than and equal to negative 89 upon 8. Now, because functions is such an important part of your P1 syllabus, I would strongly advise, and not just for your P1 syllabus, even for your understanding of P3. So if you develop your basics very well, which is only going to be through practice, I would recommend that you follow a few channels. So you can go on Medes Math to practice. If you want to start with something smaller or something basic, you can go on Corbett Math and do the practice, and then you should go on topical functions and do the questions from there on the Papa Cambridge website, okay, which I'm pretty sure you guys are all familiar with. And you should, for sequential progression in the difficulty level, you should go to CIE endorsed Cambridge, the black hardcover book, Cambridge endorsed book for P1, and you should do the exercises from your chapter 1 from there, right? This is going to really help you. Now, what are the main examiner traps in your inverse function? So number 1, you forget the restrictions, which we discussed at length here. You forget the restrictions. Number 2, you put the wrong square, you put the wrong square root sign. You either take plus or you take negative, but you are not sure why you are doing that, right? So this plus minus sign with the quadratic root. Number 3, that you are not swapping the domain and range. What did we do? We did that domain of fx is equal to range of f inverse of x, and range of fx is domain of f inverse of x. This is extremely important. Make sure that you learn it by heart and never forget it. I'm 35 years old. I did my A levels in 2011, and it is 2026. 1.5 decade later, I still remember it like I learned it yesterday only. And trap number 4 would be that you give inverse when none exists. So for example, the turning point was at 2 comma 1, and the domain started from x is greater than and equal to 1, which meant that if the turning point was right here at 2 and 1, and the function goes like this, and the domain started from 1, which means that this whole was function, then you cannot find the inverse of it, right? So you will just outright state that the inverse for this function is not possible. Now our next lecture is going to be I said earlier that our next lecture is going to be on quadratics, but before that I would want to cover transformation, which is somewhat a newer topic in P1, but I think it was added 5-6 years ago. But it is extremely important for you to understand why and how the quadratics behave as well. So that our next topic is going to be on transformations. And you'll discover why that f of x minus 3 plus 2 is not the same as f of x plus 2, right? I will tell you that y minus 3 moves the curve right side by 3 units, and y plus 2 moves the curve up by 2 units, and we are going to discuss that in detail. If you have any queries, you can WhatsApp me on +92 329 3028 485. Even if you are not enrolled in our ongoing classes, I want you guys to follow along, because I will be covering the entire, on this very playlist I'm going to cover. So subscribe to the channel, and I'm going to cover the entire playlist, the entire syllabus for P1, S1, and for A2 I'm going to cover P3 and S2 here by the end of August. So if you want to follow us on Instagram for all the updates, you can do that on @EASY Taleem, TALEEM, and I'll see you guys in the next video. Good luck.